absent people.
And it's the focus of this thing.
Okay, hopefully you remember the differentiating of inverse trig because we're going to reverse it. You at least remember what we did last lesson if you haven't yet practiced it. So we were differentiating inverse sine, inverse cos, inverse tan. And they became these lovely fractions with the derivative of the function on the top over, depending on which one it was, depended on what the denominator was. So we're now reversing that, which means that we're going to have the fraction and we'll be integrating it back into the inverse trig function. Now the two that are here are the ones that are on your formula sheet, but you'll notice that inverse cos is not there. If you remember, inverse cos and inverse sine are really similar though. It's just the negative sign. So if I was integrating f dash over square root of 1 minus f of x in brackets squared, I could either have a minus in front of that whole fraction, or you could have negative inverse cos of the function over a plus c. Okay, so that one is an option if you would like to remember it. Okay, so let's go to our questions. Hello, Ashton. Yep, you're ready? Question 1, we want to integrate dx over 1 plus 25 plus x squared. Now the dx on the top, you've probably seen that in your advanced. You can just move that to the side and it just means that there's a 1 on the top. So let's rewrite this. I'm going to have a 1 on the top. On the bottom, you'll notice that there's no square root sign. So we're going to be using the inverse tan formula here. Yep, go grab it.
Yeah.
Yes, go concentrate. Yeah. The f of x, gentlemen, what is the f of x for this question? Correct. So that 25x squared, you need to square root that, which would be 5x inside, and we want to then square that because always the function's squared. The 1, that would be in the position where the a is in the formula. I'm looking at the tan, inverse tan formula there. So you could write that as a 1 squared just to have it in the a squared plus function squared. And on the top, I do have a 1. The dx, I'm just moving out to the side. Now that is still not quite right for me to integrate. What's wrong? That's right. The derivative of that 5x, the function, the x there, that has to have the derivative on the top, and the derivative of 5x is a 5. So if I need it to be a 5 on the top, I'm going to change it to a 5, but I have to compensate for what I've done, which means I would times by a 1 over 5 out the front. So you've done stuff like that before? Yes. Excellent. So now we are ready. We can use our formula. The 1 over 5 is just going to stay sitting out the front. It integrates. It's in the perfect form now to be inverse tan of my function, which is f5x, over 1, because a would be 1, but I don't need to put over 1 if it's a 1, plus a c because it's an indefinite integral. Okay? Pretty straightforward? Let's do that a few more times. This is in 12b, correct. Question 2. Let's try again. This one's a definite integral, which means we'll be subbing into it at the end. This one also has a square root in it, so yes, we're going to be using sine. We need to put it into the right form, so let's rewrite it. We're going to leave our integral alone for a second. Start with the denominator. I have square root, and each of the things underneath that square root have to be able to be squared. So the 4 would be 2 squared. And the negative x, so that's just going to be x squared, making what my function? What's the f of x in this formula? F of x equals? Nope.
1. Negative one.
Not the derivative yet.
X.
F of x is just the x that's in that bracket, which does mean the derivative is 1. So I want a 1 on the top. Did my question have a 1 on the top though? No, the original question had a 2. What am I going to do about that? Kill it. Bring the 2 out the front. Good job, Isaac. Bring the 2 out the front. Don't forget the little dx on the end if we're being very good with our setting out. So that is now in the right form for the inverse sine. Okay, so the 2 is going to stay sitting out the front. We're going to open square brackets because it's a definite integral. It will be inverse sine of my function, which is x, over a, which is, what's a? 2. So go back here to the formula if you know what I'm talking about. So in my inverse sine, when it integrates, it's the function over a. The function is this one that's squared, and the a is the first one. Okay, that's why I have to change them into that form. Close these square brackets, and we now get to put our values on here. We're integrating between root 3 and 1, so let's sub them in. Leave the 2 sitting out the front, open up a bracket. It's going to be inverse sine of, sub in root 3, it would be root 3 over 2. Then we subtract, sub in the second value, which is inverse sine of x is 1 over 2. Okay, so your default is to always give answers in radians, please. So on your formula sheet, yes, yes, but jumped ahead of me a bit. On your formula sheet, you would use your exact value triangles to find inverse, or what sine of what is root 3 over 2, and it is how many degrees? 60 degrees, which becomes pi on 3. Yeah? Is that too big a jump, or does everyone follow that? You're good? All right, so that first one is pi over 3. And how about inverse half? It's 30 degrees, which is pi on 6, so minus pi over 6. Don't leave the 2 there, sorry. Why? Oh, because it's going to cancel out. We want to make it tidier, so we would get we would try to put those 2 fractions together there. What is pi over 3 minus pi over 6? Well, if I want a common denominator, I would times the top and the bottom by 2 to make a 2 here, and then this would become a 6. All right, gentlemen, back to it. 2 pi over 6 minus pi over 6 is 1 pi over 6. When you times that by the 2, you have 2 pi over 6 again, which simplifies down to pi over 3. All right, question 3. Let's do it again. Notice the lack of square root sign, which means we're going to be using inverse tan. Let's put it in the right form. So let's do our integral here and start with the denominator. The 49 is the same as 7 squared. The 25x squared is 5x squared. So that means 5x is my function. I currently have a 6 on the top. Is a 6 the right thing to have on the top? No, it's not. Move it out the front. It's the wrong number. What number do I need on the top?
5.
A 5. Beautiful. How am I going to compensate for adding that 5 in there? Divide by 5 out here. Perfect. Dot dx. So now, how do we integrate this? It's a bit annoying that our formulas are on the other page. Look back to that tan formula. Oh, I went too far. One thing I didn't have to use last time was this part, the 1 over a out the front. Now we need it because our a is something other than 1. So we start with 1 over a. What is my a?
5.
The 7, good. That 6 over 5 is just sitting out the front. 1 over a will be 1 over 7. And then it will be inverse tan of my function, which is 5x over a, which is 7, and then plus the c because it's an indefinite integral. And all I would do is just tidy up those front two fractions. So 6 times 1 is 6, 5 times 7 is 35, and then inverse tan 5x over 7. Okay, so those questions, pretty straightforward. We just have to move a few numbers around, but we can also use exponentials. You're doing have you finished exponentials in advanced yet?
We've just, we
Yeah?
did that.
Good. All right. So you know how to integrate and differentiate exponentials, and we can still use our formulas. No square root sign on the bottom, so inverse tan again. Let's change it all around. On the bottom, 1 is simply 1 squared. E to the 2x, remember we need to have that in the form of something squared. Yes, it is e to the x squared, because when you expand powers with powers like that, that would be a 2 times x, which is your 2x, right? Okay, on the top, I need the derivative of my function. What is the derivative of e to the x? E to the x. Is that what I had to start with? Yes, the original fraction did have e to the x there, so I don't even have to change anything. Okay, so straight into my inverse tan formula, which is 1 over a would be 1 over 1 out the front again, so don't really have to worry about that if it's a 1. Inverse tan of my function, which is e to the x, and then don't forget your plus c. All right, question 5. Good. I'm glad it was easy.
Oh.
Oh, no, that was it. Question 5. All right, you people who already know how to do it, let everyone else concentrate. Change the question into the right form. Start with the denominator. So the 1 is a 1 squared. X to the power of 4, how would I change that?
X to the power of 2.
Very good. What is the derivative of the x squared, which is our function?
2x.
Correct. So I need a 2x up here. I didn't have a 2x, so I just had an x. How do I have to fix my integral? I've times an extra 2 in there, which means I need to divide that 2 back out by putting a half in front. Don't forget the dx at the end, and now we're ready to integrate. So integrating, the half will stay out the front. The inverse sign will have my function, which is x squared over a, which a is 1, and then plus a c. Done. Question 6, time to do something a little bit more interesting. In this question, it says, start by differentiating y equals, gentlemen, paying attention? Start by differentiating y equals x inverse sine of x. Now, why on earth would they make us do that? We want to integrate. First of all, what do you notice about that x inverse sine to the x? It's a VOOV, it's a product rule, okay? And finding that derivative means it's going to help me find a rule that's going to help me to integrate another problem in part B. Okay. Actually, no, it's actually in the same part. I want to find the primitive of inverse sine of x. Okay? All right, so let's first of all do what it says, and I want to do dy over dx. I'm differentiating, so this is back to the first lesson. Now, do we still like to write our u and v over here on the side, or are we starting to shortcut that process?
I'd like to know.
You'd still like to write it?
Yeah.
All right, so u is going to be the x, and v is going to be the inverse sine of x. Quotient rule.
Quotient. Is it?
So this is
be specifically which one is which?
Yes, the u has to be on the top for quotient rule. This one, it doesn't actually matter, no. Not right now. Okay, derivative of x is 1. The derivative of inverse sine, okay, The function is the x. Do you remember the formula? It's going to be 1, no, over square root of 1 take x squared. No, it's on your formula sheet. Okay, putting that into VUV, we have v times u dash. Gentlemen, please. Inverse sine of x. U times v dash. Yeah, let's put the x on the top with the 1 over the square root of 1 minus x squared. Okay, if that is the derivative, Ben, put your phone away, then the integral is of inverse sine is what we're trying to find. This is the goal here. I want to find the primitive or the integral of inverse sine. Differentiating and integrating are the reverses of each other. So if I've just differentiated and found inverse sine of x plus x over root 1 minus x squared, if I integrate all of that, stuff that I just found, it's going to reverse the process and it's going to go back to what? Correct, what I started with before I differentiated, the x inverse sine of x. The problem is I don't want to find the integral of inverse sine and that fraction. I just want the inverse sine. But it's an equation that I've made up there. So how about I split this so that I'm going to put another integral sign in here. So I'm splitting it into two integrals. And I move that second one across to the other side. So the integral or primitive of inverse sine of x dot dx is going to be equal to x inverse sine of x minus the integral of x over square root of 1 minus x squared dx. Okay, now how? We've got part of it. We just need to find this last integral here. How can we integrate that? Now, I'm hoping some advanced stuff is going to help you in here. We would, because we, no, it's all right. What is the function on the bottom? So this is an inverse, the x squared, right? What is the derivative of the x squared? Correct. But, 1 minute. Sorry? I was just double checking my formula. Yep, it fits. We're good. Okay, so if I need this to be a 2x here, what do I need to do? Oh, sorry, you're right. It is a 1. Thank you. Yep, let me put my brackets in. There we go. That's my function, is just the x. The derivative is just a 1. Now, here is my problem. Here is my problem. Because it's always the function squared on the bottom. Here is my problem. The problem is that I can't just add an extra x into the numerator of my integral, right? I can't just like divide it back out again at the front, okay? So instead, I'm going to have to use a substitution into this, integrating by substitution, which is the complicated part that we were coming up to. So I'm going to be here on the side. I'm going to say let the u equal what is underneath my square root sign there, the 1 minus x squared. Now, I'm not sure how you have seen this before, but if I want to differentiate that, du over dx would be equal to negative 2x, which is a good sign because there's my x appearing in there that I need. Now, often I like to skip that step though and go straight to du equals negative 2x dot dx. Is that what you guys are used to doing? Move that dx across the other side?
No.
You haven't seen that before? Oh, they haven't done this before? Okay, so what I'm going to do is I'm going to change that integral to be an integral in terms of u instead of x, so that I can put it into a form that I can actually integrate. So let me rewrite my question. I now have, I'm just going to go equals under here, my x inverse sine x, it's fine, it's just sitting at the front, minus, now, the x on the top, I'm just going to leave it there for a second. On the bottom, the 1 minus x squared is what I called u, right? So that is the square root of u that I have on the bottom. Instead of using dx, dx is equal to, actually I should have done one more step. I should have got my dx by itself over here. How would I get the dx by itself? Divide the negative 2x across the other side. So it would be 1 over, or du over negative 2u. Because then I can replace my dx with that to be du over minus 2 x. Sorry, that's an x. Now, I don't really like, and it's a little bit naughty, don't really like to have both x's and u's in my thing, but by writing it like that, you can see that my x here and my x on the bottom there will cancel off. Okay, so it's kind of all right because they're disappearing. And I'm just going to integrate that lovely thing there in terms of u. So let's take it out of fraction form, and it'll be x inverse sine of x. It's 1 over square root of u, which is u to the power of a half. So that would be integrating u to the negative a half in terms of u, right? And the minus 2, thank you. I'm going to bring that out the front. I'm going to bring out the half out here. So the minus 2, it'll become a plus half. Thank you. So that minus 2 on the bottom, if I bring it out the front, I've got a minus and a minus becomes a plus. And because it's on the bottom, it's just a plus half. The 2 is on the bottom. You could put it inside, but I want to keep that u all by itself so I can integrate it.
So you just divide, you just times it by half, just get rid of that.
No, I'm not really timing it by half. I'm just taking this minus 2 here, which is already on the bottom.
Oh, okay.
And I'm literally just moving it out the front.
Yeah, okay.
That's it. Okay, integrating, just a nice u with a negative fraction there, but that's okay. We add 1 to the power. Let's just write all this down again. I'm running out of room. Hope you've got some room. Add 1 to the power becomes u to the positive a half. Divide by a half is the same as timesing by 2. Okay, and we have integrated it, so that is we will be plussing c there, but I need to put that back into x. I'm integrating in terms of x. U was just something that I used to help me integrate, right? So let's, one more line, if we can squeeze it in. I need to go back and sub in that my u was this 1 minus x squared. Because when you integrate, we change colour, you add 1 to the power and you divide by the power. But instead of dividing by a half, it's easier to times by 2. It's like the reciprocal, right? Okay, so x inverse sine of x, and the half plus 2, just 1, gone. And the u, we're changing into 1 minus x squared. Because it's a power of a half, it will have a square root sign over it, plus c. That one was a good one, wasn't it? Not quite as easy as those other ones. Okay, there is a part B to this question. It says, find the shaded area under the curve for y equals inverse sine of x between 0 and 1. Okay, so it's putting some, it's making this a definite integral so that we can find an area. The area, let's start from the beginning. What it's asking, integrate between 0 and 1, and I'm finding the area of inverse sine of x. Okay, but we have just spent a lot of time and effort trying to find out how to integrate inverse sine of x. don't do it again. We know that inverse sine of x integrates that lovely green line up there that I wrote down, which was x inverse sine of x plus the square root of 1 minus x squared. Okay, between 0 and 1. So we just have to sub in and evaluate what that equals. So sub in the 1 and we get 1 times by inverse sine of 1 plus square root of 1 minus 1 squared. Oh, that's going to disappear. Okay, then minus, sub in the 0. So it'll be 0 times by inverse sine of 0. That's going to disappear because 0 times anything. Plus square root of 1 minus 0 squared. That's still 0. Okay, so what is left with all the things that disappear? Inverse sine of 1 is what? On your sine graph, where is the sine graph equal to 1? I think you said it. Pi over 2. 90 degrees, right? The sine graph starts at 0, it comes up, it does its thing. So it's at 1 at that high point, which is at 90 degrees or pi over 2. So this first one here, that's pi over 2. 1 minus 1 squared, that's just 0. Square root of 0 is just 0, so it's not doing anything exciting. Minus, now be careful with your minus in case it has to expand through. We had 0 times by inverse sine of 0, that's just all 0. And square root of 1 minus 0 is just 1. So we have left pi over 2, and expanding the minus through would be a negative 1 is our answer. But because we were asked to find area, is there something else I should include? Yes.